very busy with Hurricane Milton kind of sweeping out a week for us, and with finals already, upcoming. So thanks for being here, taking the time to be an active member of this club. So this evening, we will be going over our project updates. As many of you guys know, we've all been starting with build days and getting ready for flight and launch days. So we'll be hearing from the project leads and what they have to share about that. And then we'll be going over upcoming events. We'll do a recap of what we've gone through October and for the last few weeks of the semester. And then we've got important information about SciTech 2025, so stay tuned. And then, of course, we have our guest speaker. We will be hosting Whitney Coyle, a launch vehicle acoustics researcher. This doesn't want to work. Maybe not. Technical difficulties? Nope. Give us one moment. Is there? Oh, that's not the right one. Almost there. It's oh, there we go. Okay, here you go.
All right. So now that that's out of the way, if this is your first general body meeting, we welcome you. Thank you guys for coming out. This is a little bit about who we are. So we are the University of Central Florida student branch of AIAA. As of right now, we have one of the largest AIAA student chapters in the nation. And what we do is we design hands-on technical projects. We also do that along with networking with peers and mentors, and we just pretty much explore the world of aerospace.
All right, so this is this year's e-board. So I'm Emma, I'm the president. This is Christian, our vice president. Amelia is our secretary. Alessandra is our treasurer. And we've got Nathan, our projects chair right here. We've got two faculty advisors, Dr. Coffin and Dr. Elgahari. They are both MAE professors here at UCF, and they both lead research labs within the CECS department.
All right, everyone. So now I'm going to talk a little bit about our committees. So new to this year, we have 3 committees. We have our sponsorship committee, our events committee, and also our media committee. So the first committee that we're going to show right here is going to be the media committee. This is everyone that is on the media committee. We have our newest member, Franklin. If you're in the crowd, raise your hand. Hi, Franklin. Pleasure working with you. Next, we have our events committee. This is everyone on our events committee, and our newest member for this committee is going to be Lee. Lee, if you're out in the crowd, raise your hand. Hi, Lee. And then last but not least, we have our sponsorship committee. This is going to be the one that I'm in charge of. This is everyone. And yeah, so a little bit about all of our committees combined. Starting with media committee. You're good. Starting with media committee, they're going to be primarily responsible for capturing projects and member involvement through photography and videography. They are also going to be primarily responsible for sharing club events and news through graphic design and social media. Next, we have our events committee. What they do is they coordinate club events on and off campus. So this includes anything and everything of socials, volunteer opportunities, and local fundraising. And then we have the sponsorship committee. We are primarily tasked with external outreach to industry companies to gain funding and support for the club. So this is how we're able to provide all these amazing projects for you guys. And yeah.
All right, so now we're going to welcome up Skylar and Nico for events committee to do give us a quick recap. Here you are.
Hi, I'm Nico.
I'm Skylar.
And we're events committee with Lee. Oh, so a little recap. So recently we just finished our Build the Boo Grant fundraiser. So essentially, you use these nice little pieces of paper. You say who you want it to, who it's from, and you give a little message. You can be nice, you can be mean, whatever you want. And also we did something new since UCF is really big when it comes to their rubber ducks. We did our own rubber duck thing too, and we actually made it customizable. So all you missed out on the rubber ducks, I'm sorry, but we do have plans on doing it in the future. So if you're looking forward to it.
Okay, and then our other event was the Halloween costume contest. So over here we see our winners. It was first, second, third place, and a group picture. And
give a round of applause.
Yeah. Yeah, and they won cash prizes too, so that was a bonus.
Thank you. All right, now we'll be going over some upcoming events. First up, we have an undergraduate research forum. UCF is a huge research university, so I mean, we are committed to world-class research. We are home to more than 50 centers and institutes. And we have award-winning faculty that lead these research labs and teach some of the classes that you may be taking. So with this opportunity at our hands, we wanted to invite some of the research labs to present to you guys, so you guys are aware of what kind of research and projects goes on in the CECS department. So next Thursday, November 14th at 7 p.m. in this room, we will be hosting 6 labs from CECS. So if you're interested in learning about the projects that we have at UCF or curious about joining research, this is the event for you. We also have a volunteer opportunity this weekend. We have Maker Faire Orlando going on at the Central Florida Fairgrounds and Expo. So this is basically like a large science fair. There's people from all over the community that come and showcase their creations and inventions, and it's just a great way to see different exhibits and vendors that are here in Orlando. So this was us last year. We got a little group together and we volunteered. So if you're interested in giving back to the community this weekend, we have that going on. The link to sign up will be in our link tree as well as in the minor announcements channel of our Discord. If you are interested in volunteering with some people from the club, a few members from eBoard will be volunteering Sunday from 9 to 1 as the greeter. So keep that in mind if you're interested in signing up. All right, and now I'm gonna invite Ian and Connor up to the stage to talk about Flight Day.
Hello, I'm Ian Doherty.
Connor Tyson. I am quads lead. So we're gonna have practice fly days every Saturday. We didn't have a few ones in the past because Hurricane Milton closed the park down. So we will have them going back up again. We're gonna have one like this weekend. So yeah, it'll be like at 2 o'clock Sunday. Little big econ trailhead. You can go. You can fly any kind of RC aircraft that you have. We have a few stuff that you can come out and fly. Yeah.
Additionally, we do actually have an option to change the time of flight day from Sunday at 2 p.m. to Saturday at 2 p.m. potentially, depending on weather. I know that for the previous couple of weeks, we'd had several issues with weather, including those hurricanes, and then additionally the park being closed for several weeks because of a hurricane. So we have an option to change the time. We'll announce it on Discord if that's the case. If not, it'll just be the standard time each week. So we hope you'll come out and learn to fly.
Thank you. All right, next up, SciTech. So what is SciTech? This is a national conference hosted by AIAA, our parent organization. It is one of the world's largest research and development events globally. So this is a great chance to network with different industries within the aerospace and other engineering fields. There's a chance to learn about all the different technical papers that are submitted by students and researchers all over the world. And then there's a huge expo hall where you can just learn about the latest aerospace news. So this will be held in Orlando in January 6th through the 10th. This coming spring. So we have been working to guide you to provide free tickets for a day at the center for the club. So Alessandra has been working with SGA and all the financial aspect of that to be able to guide you guys through getting an individual CRT. So for those who scan the interest form last GBM, we'll probably receive an email. If you're interested, you can scan this now, and then you should be receiving an email from Alessandro that will guide you through the process of getting a CRT. And if you have any other questions, you can just let us know.
All right, so now we're going to talk a little bit about our projects and where they are at in their build process. So first and foremost, we have our AVD. Welcome our AVD leads.
Thank you, sir. So we are AVD. I'm Austin.
I'm John.
I'm Carmina.
And I'm Ian.
Basically what we do is we teach you from the ground up to design and build an RC aircraft. You will learn things like solid mechanics, or SolidWorks, and XLR 5. It's 2 semesters. Unlike the rest of the projects, they're all 1 semester. We are 2 semesters. So unfortunately, we are full at the moment, but starting next year, you can come back and join us. But after this semester, we have, in 2 weeks, we have the presentations at literally 2 weeks from now, 21st, in this room, actually. And then after that, spring semester, you'll get your materials where you start building your aircraft. You finalize your design over winter break, and then you build it, get the materials in the first 2 weeks of we have meetings. So literally, you don't need to have any experience. For those of you that are new here, you don't need any experience whatsoever. You could be a freshman. We have plenty of freshmen joining. I joined as a freshman. He joined as a freshman. Pretty much all of us joined as a freshman. Didn't know anything. So more than welcome to join us. We'd love to have you guys next year. Anything?
Covered it. You got it. Thank you. Thank you, AVD. All right, next up we got rocket design.
Hey guys, we are Rocket Design. My name is Lucas Bello.
My name's Nico.
And excellent. No. Okay, good. So Rocket Design is a program where we take you through the design, the manufacturing, and the eventual flying of mid and high power rockets. So for this semester, we have our launch day this Saturday. Very exciting. We're going to be out in Palm Bay launching 19 rockets, mid power. Very exciting. You know, the students have worked throughout this whole semester through the design and the build process. So it'll be fun to see, you know, what'll happen, but it'll definitely go up.
And then for next semester, we'll be doing our L1 certification program. And that will consist of bringing the members through building their L1 certification high-powered high-powered rockets. Those are individually built. Everyone builds their own. And if they're successful, they of course get a certification, which is a great resume booster, as well as allows you to buy more high-powered rocketry motors.
Thank you.
All right, and now welcome our quad leads.
I'm Connor Tyson. I'm the quads lead.
I'm Eric Bobadilla. I'm the co-lead.
I'm Gabriel Johnson. I'm the assistant lead.
So in quadcopter, we teach you to design, build, and fly your own quadcopter. What we do is we use SolidWorks. That's where y'all used to design it. And then we'll laser cut acrylic, and that's where y'all used to build it. And of course, we use FPV electronics. That's what, you know, the electronics we used to use. For this, right now, our project is closed, but we'll be opening up next semester. Right now, our current progress is that we're cutting the acrylic out, and then we'll be hopefully flying the weekend after next. Some people might be able to get their quads built this weekend, be able to fly. But yeah.
Thank you. All right, next up we have hovercraft design.
Alrighty, I'm Ethan.
I'm Vivek. I'm taller Ethan.
And we are the hovercraft design competition. So each semester we do it. Each semester we do a different game. This semester we are doing jousting. Like quads, we're a per semester project. We are unfortunately closed off for this semester. However, we are going to be reopening in the spring. We're probably going to be doing a stunt race in the spring. So if that's something you're interested in, definitely stop by. Also similar to quads, we just take you through the entire process. Recently, we've been going into the lab, actually cutting out all of the hovercrafts, laser cutting all the wood, and hopefully pretty soon the craft should hover. We're doing assembly right now in our meetings. All right, that's about it.
Awesome. Thank you.
Thank you, guys. All right, and next, welcome our glider design project.
I'm Zach. I'm the glider design lead. This is our first semester here with the AIAA. So we're kind of like building upon everything for this project. Right now we're laser cutting our parts and then assembling it. As like other clubs, we're one semester, so we're closed right now. But then next semester we're restarting it all. Then you can join, and then we'll go from the beginning, designing it in SolidWorks, and then laser cutting it out. We have our flight competition in I think it's next week or the week after, where we're gonna fly MC who can fly the longest from what they've designed. So that's our glider design.
All right, and now we're gonna have a Bloom project update from Nathan.
Hi, I am not Nadav. Nadav couldn't be here because he's out of state, so I'm just going to explain what's going on with the Blimp project. But this is an experimental project, so it's a little bit different from the rest of the projects that we offer, where it's everybody's sort of on the same team working together to create a final product. Earlier this week, they submitted their budget that's currently being reviewed by our treasurer and will be submitted to SGA shortly to start getting the funding for it. Over the past semester, they've been working on doing research and figuring out what types of components they're going to need to design and build this blimp. This project is really not going to close until it's finished, so if this is something that interests you, please join and help out. We're going to need all the members that we can get. Coming in the spring semester is really going to be starting to do the hardcore design and building of this blimp, which is like you can kind of see from some example. The first two example pictures, not the last one. That is supposed to be an RC blimp to sort of fly around campus. So yeah, this is a really cool project. And if you're interested, please come out.
And last, but certainly not least, we have our DBF. Please welcome Zach.
I know it's been a month, so it's been a little while, all right? But what do I always start my speeches off with? How's everyone doing tonight? Amazing. I'm hearing responses from here. Let's get it from the right side. How are we doing? Thumbs up. Great. Amazing. That's what we like to hear. I'm Zach 1. Avery is not here. He's off getting the milk, so it's just me today. But before we dive into it, right? So, remind me what day it is today? The 7th. So last week, something quite incredible happened for DBF. We submitted our proposal. We are officially in consideration. A cool fun fact, 162 proposals got submitted, of which 110 will be taken. So just quick, come on, round of applause for the team who worked so hard on this proposal. Come on. There we go. All righty. So I'm going to keep it quick because I'm technically already over time. We are a national competition project. At the end of the spring semester, we go off to Tucson, Arizona against a bunch of other universities to show how much better we are than they are, because we are the best, right? We're putting in a lot of work. We're putting in the CAD modeling, right? We're going to have one by the end of next week. And if any of you want to join in on it, we always need more people. It's hard work, right? But it's good work. Thank you.
All right, so now I'm going to talk a little bit about our Lockheed Martin mentorship update. So as of recently, if you got accepted or if you got denied, you should have received an email either way, whether you got in or whether you did not get in. We apologize for the delay. It took us a little bit of time to get the official list of everyone who got in / did not get in, so we apologize for the delay. But for those of you who did get in, we hope you're enjoying it. We hope you're learning something very valuable, especially regarding your careers. But for the people who did not get in, we have some good news. We are doing it again in spring, so please stay tuned for that. All right, and also next week on November 14th, we have our resume workshop. So AIAA is sponsoring a resume workshop that Lockheed Martin is hosting. So it's going to be online over Zoom. It's also going to be the same day of the research forum as well, but it's going to be before. So please put that in your calendars and don't get any dates confused or times confused or stuff like that. But like I said, November 14th, so the research forum day as well, from 4 to 5 p.m. So like I said, it is going to be over Zoom. The first 30 minutes are going to be a general guideline of how your resume should look and stuff like that. And then the latter half, 30 minutes, are going to be like, I think they're going to break off into small groups. So that's where you're going to be able to get like one-on-one personalized feedback of your resume and how it holds up to the industry. So yeah, if you want to scan the QR code, make sure to do that. It's also going to be our link tree as well. So if you guys also have any questions, there's an email right here. Make sure to email that if you have any questions. And yeah, I think that's everything for that.
All right, so our Central Florida section chair, Dr. Walter Hammond, was supposed to be here tonight to kind of talk about this Central Florida section. Unfortunately, he's not here, so I will cover his slides. But we're trying to keep close relations with our national organizations. So the way it works is that we have the big parent national organization, and that's broken down into different branches. And then within those branches, there's the student sections, us being one of the largest. So AIAA has different groups where you can join. So we're on the student level, and then there's also young professionals for people that are either going into industry and working their way up. And then we also have experienced professionals and educators and researchers. If Walter is here, if you'd like to come up and talk more about it.
The Central Florida section is shown here, and on the bottom, we're on YouTube, but on the bottom lower right, in the bottom lower right is our website, AIAAcentralflorida.org. It's pretty much set up, but and so that has all of our events, including this event, on that website. And let's see, did you cover about? We basically have something to offer for everyone. For example, next week on the 14th of November at 4 to 5 o'clock, we're having a workshop with people from Lockheed Martin, hiring managers, and I'm going to send Emma the link for that, and you can participate virtually. You log in, and you're going to be talking to professionals at Lockheed Martin who might have a job that you can do. So I'll be sending that notice out. So we have a highly encourage you to join when you graduate, and don't just quit AIAA because you're no longer a student. That's all the more reason to join AIAA, because it's valuable for your career. Okay, next slide. Oh, yeah. Okay, this just shows our student chapters. We got one at University of Florida. We don't have one at University of Tampa, nor at the University of South Florida, but we do have members in that area. And guest speakers, for example, on November the 21st, we're having a person talk about satellites and how they operate and communicate around the world. So that should be on our website. We don't have the venue yet, but if you check on the website, you'll find it in probably by this weekend. Okay, next slide. Oh, tours. Again, looking at our website, we're sponsoring a tour in, I think it's December of the, I think it's December of the January, no, it's January of the Cape Kennedy and Space Force complexes out at off Cape Canaveral. So that's a tour that you have to sign up for. Okay, next slide. Is that it?
Yeah.
What about the one that Max?
We covered that before this one.
Oh, okay.
Yeah.
Thank you. Any questions?
Thank you, Dr. Hammond.
All right, and now we have our merch. So if you guys want an awesome way to represent the club, this is how you do it. Starting off, we got our 2023 to 2024 shirts right here. We also have our mystery bags, and what's going to be inside the mystery bag is a previous AIAA designed shirt from one of our previous years. It's a great way to get an AIAA shirt at a discounted price. We also have our flight tags, so you can put on pretty much anything, backpacks, water bottles, you name it, and go on there. We have our stoles for those of you who are graduating, and the last thing we have are our 2023 to 2024 polos. So for those of you who are not graduating, what am I saying? For those of you who are going to SciTech or planning to go to SciTech, that's a great way, something good for you. So get it. Get anything you like.
All right, so let's talk about membership. We have AIAA at UCF, us, and AIAA Nationals, our parent organization. So what's the difference? AIAA at UCF will span your scholastic career, and AIAA National will span your professional career. So as we had mentioned before, we offer design projects, local networking within UCF, and other club socials and volunteering opportunities like that. Whereas with Nationals, you have access to national conferences such as SciTech and other aerospace publications. It's also great for industry networking, and you can also have the opportunity to join technical committees and other resources like that. So. All right, so this QR code will bring you to our link tree. That's where you can access our social media, our website, our Discord and things like that. Upcoming event up for all the different volunteering and resume workshop opportunities we have for you guys. Next up, we will have Whitney Coyle, who is the launch vehicle acoustics researcher and speaker, and some of her students. But for now, we are on pizza break. So if we could have 2 lines on either side, you can pull out your QR code, membership QR code, get that scanned, and get yourself a slice of pizza. And now it's time for our guest speaker, Dr. Coyle, and her undergraduate research student, McKaylee.
Okay, hello. Yes, my name is Dr. Coyle, and I am a physics professor at Rollins College, just down the street. And I'm really excited to be here. I met Emma this summer at an AIAA meetup, and she said, "Hey, you do rocket stuff? Do you want to come tell us about it?" I said, "Yes." And now it's November, so I'm here. What I'm going to tell you about today is some of my research that I've been doing for the past 2 years. And if you don't know much about Rollins, we're very small. I mean, our physics major probably only has like 20 people maximum, but we are very invested in including students in our research. So that's why I brought McKaylee with me. She's done a lot of really good work, so I wanted to give her credit for the things that she's done. So a little bit about me. I studied acoustics at Penn State for my PhD. Before that, I was a music and math major. Everybody's like, wow, that totally comes together. I'm like, yeah, no. One of the things I did for my master's was I studied outdoor sound propagation, and I was doing computational modeling. And that was at Penn State. And then my PhD, I actually spent most of it in France doing clarinet acoustics. So I was studying the physics of musical instruments. More recently, I've gotten into rocket noise because, first of all, it's very cool. And of course, very relevant to the Space Coast and everyone who's coming to places like UCF and Rollins being interested in NASA things. And so, yeah, so we started that about, I guess it was in 2022, and that's when McKaylee came along as well. So I'll give her the mic for this.
Hi, everyone. My name is McKaylee. I am a senior at Rollins College. I'm a physics major, and I've been working with Dr. Coyle for about 2.5 years now. I also work with her collaborators at Brigham Young University in Utah. And I have spent my past 2 summers doing research at BYU and kind of bringing that knowledge over to Rollins. I will be graduating in a month from Rollins, and then I will be interning at NASA Marshall this spring, where I'll continue my work on SLS acoustics. And then in the fall, I will be starting my PhD with the research team at BYU that I've been working with for the past 2.5 years.
Okay, so the people in this room are probably not surprised by a plot like this. What we're showing here, of course, is that rocket launches are becoming more frequent. Nobody in here is surprised by that. But what you may not think about, because I doubt everyone in here is interested in acoustics like I am, is that that also means lots and lots and lots of noise coming to us, and something that perhaps was not thought about too deeply until now, hopefully, when these rockets are getting so big that it's really going to be an issue if we're launching upwards of 200, 300 launch vehicles from Cape Canaveral every year. So that's one of the reasons why we should care, right? If there's a lot of launches, a lot of noise, this could be harmful to the communities around these launch pads. So for mechanical engineers and aerospace engineers, these are some numbers that you might appreciate. One of the things that we're going to talk about is how the noise from these launch vehicles is pretty proportional to the thrust of these vehicles. So we put some numbers up here just for you to know. Are the rockets to scale? No, probably not. It's just a PowerPoint. But the numbers are legitimate and kind of scary, at least to me, because I don't work with thrust numbers that much. But think about these rockets getting bigger and bigger. We're going to get more and more noise. So this slide is going to give you a sort of GoPro measurement, so a GoPro video of the Delta Heavy launch. This was not one that I took, but just to give you an idea of the noise level that's going to come off of this thing. I'm guessing the speakers will clip a little bit, but we can just give it a shot and see what we get. No, but everyone in this room probably had different thoughts watching that because, again, I'm an acoustician. I'm worried mostly about the sound. You might have had other ideas, but what I liked for you to come away with this presentation with is at least an appreciation for why this might matter and in your future careers that you can, for us acousticians out there, we would like you to think about it. Okay, so one of the things we're going to talk about today is the difference. We need to have numbers on these things, right? We like to have quantitative information. And we're going to say things about sound pressure and about sound power. And just to be very, very clear that there are different things. We have a source characteristic in sound power, and what you are receiving is a sound pressure. I don't know your background in acoustics or anything like that. So we're going to start with some basic things and talk you through just so that we're all on the same page for these measurement things.
Great. Okay, obviously graphic design is not my skill set, but that's okay. I'm going to explain to you the difference between pressure levels. These are the two main metrics we use to quantify rocket noise. They're both measured in the logarithmic quantity decibels, but they are not the same thing. So I'm going to give you a little bit of an analogy. Like Dr. Coyle mentioned, sound pressure levels are a propagation characteristic. So they're going to change depending on how close you are to the vehicle. I'm going to give you a little analogy. Imagine you're standing in a room with a light bulb. Depending on where you are standing in the room, the light bulb is going to be a different level of brightness. If you're standing very close to the light bulb, it's going to be bright. If you're going to be standing on the other side of the room, the light bulb is going to be very dim. This is like sound pressure levels. Up close to the rocket, you'll have a larger sound pressure level. Farther away, you will have a smaller sound pressure level. Now, sound power is not like this. Sound power is going to be constant regardless of where you measure it because it describes the source. Again, with our light bulb, the power value or the wattage of our light bulb is not going to change depending on where we are standing in the room. If you're up close to the light bulb, it will be 60 watts. If you're on the other side of the room, it will still be 60 watts. This is like the sound power of our rockets. Again, our closest measurement stations will measure the same sound power value as our farthest measurement stations. Now, just as a reminder, this is some of the math we use, but both of these metrics are measured in the same unit, decibels, but they are not the same thing. One of them describes a power value, one describes a pressure value. Just keep this in mind moving forward. You're going to see a lot of numbers put out here that are measured in dB, and it's going to be very important that we clarify to you if we're talking about sound power levels and sound pressure levels.
Thanks. Thank you, McKaylee. So one of the ways that I got into rocket noise measurements was by getting an invitation from my colleague, Dr. Kent Gee from BYU. They have a very big jet noise acoustics group, and I've known him for quite some time. And he said, hey, you're down there by the rockets. Would you like to participate in the only acoustic measurement happening at the Artemis 1 launch? And I was like, I can't say no, of course. So what we did was we got a group of people together. We had lots of measurement stations around, and this was August 2022 when we started, and then it scrubbed, if you don't remember, a lot. And so we picked them back up and tried again. Finally, almost exactly 2 years ago in November of 2022, it launched. It was wonderful. Was anybody around? Anybody watch it? Yeah, it was pretty cool. The tricky part about watching rocket launches when you're an acoustician is that you can't make noise. So when you're really excited that it finally launched and you can't talk for 20 minutes, it's really difficult. But okay, so we got our group together and we set up our measurement stations. This is just one example. So of course, rocket, if you weren't sure, press, cameras and whatnot. And behind it, we're about 1.4 kilometers on the crawlerway away from the launch pad. And what you're seeing here, these are just windscreens. Like those aren't the actual microphones, right? The microphones are pretty small, but those are windscreens with bird spikes on top so that we don't get people? No, not people, definitely animals trying to take our microphones away. Of course, we weren't able to just stay on base. We had to set these things up and leave them for quite a long time. So underneath this guy, we have a battery and the computers there. And also over here is a solar panel where we're like, please, please, please don't die before this thing launches. So these are some more examples, less glamorous, okay, much less glamorous. There were some community locations where Michaela was out on a dock in Titusville. I was much further away. I'll tell you that story another time. And but these are the other stations, some of the other stations that were actually on base. So we had 14 stations that we set up, and luckily, from what I recall, all of them actually got data. Yeehaw! So that went very well. But that is a lot of the data that we're going to show today came from that launch. We have since measured lots of other launches, but that's what we're going to show you for today. So if you weren't there or you did not see this, I will show you. Makes me happy every time.
7, 6, 5. 4-stage engine start. 3, 2, 1. Boosters in ignition. And liftoff of Artemis 1. We rise together back to the moon and beyond.
We use that quote all the time because we've watched that video so many times. Back to the moon and beyond. Okay, so from that was November 2022. Very quickly, because we knew we were the only acoustic measurements happening, we had to write some papers, right? You got to get your data out there, make sure that people know what we did. So the first paper actually took a while to get edited, but it came out in February of 2023. And there are QR codes here if you want to check it out. I can always share my slides with you later if you're interested. A while later, Michaela was first author on a sound power paper. So the first one was really more of the sound pressure characteristics from this launch, from the different measurement locations, and I will show you some of that data very soon. And then the sound power paper came out a little bit later, all in the Journal of the Acoustical Society of America. So these are some of the plots that you would find in that paper. So I'll talk you through what we're looking at. Up is the pressure waveform, so pressure as a function of time. On the bottom, you have an overall sound pressure level, so notice it's in dB, also as a function of time. And these are two stations that we had set up. Station 7 was that one I showed you on the crawlerway, and Station 9 was on the opposite side of the launch pad, but a similar-esque distance away. And hopefully you have enough intuition about sound to think about, well, if it's a little further away, those levels should be a bit lower, and they are, right? There are some specific instances that we're pointing out here, like the ignition overpressure and different things. You also have this yellow line showing me the peak, like time, right, where we got the peak level in time after, this is time after liftoff. So this is the place where we would have the peak pressure level. Okay, so we're looking at overall sound pressure level. So I have a peak there around, right, like 18 seconds. From this plot, I can't say much else than, right, when in time. Usually in acoustics, we're more interested in a frequency content, and that's something that we'll talk about here in a little while. So you may look at this plot and think, okay, cool, like, what does that mean, 400 Pascal? It might worry you, or it might not, right? If we don't have a good feel for, right, like what is a Newton, right? When you first learn physics, then you can't be surprised if your answer comes out to be like 1,000, right? So just as some numbers to give you an anchor, so a jet engine at 30 meters would be 632 pascals, so 150 dB, and that's flat dB. So yeah, that's very loud, right? So if we go back to this plot and we're getting to, right, we're getting to a peak around 400. That's getting up there, right? Definitely would hurt you. Okay, I'm gonna pass it.
All right, okay, so you just saw running sound pressure levels as a function of time, but often one of the things we care about is the maximum noise event, or the peak sound pressure level, which is what is shown here on this map. So here are 5 of our different measurement stations from the Artemis 1 launch, shown with their corresponding distances from the launch pad and their maximum overall sound pressure levels. Notice again, because this is sound pressure, closer to the launch pad, we have larger levels. Farther away, our levels begin to decay. Now, in addition to sound pressure levels, we can also calculate the sound power of SLS, which was found to be 202 dB at all of those measurement stations. Okay, so I've shown you a lot of different numbers, and you probably have no idea what any of these mean. So let's try to put it in context a little bit, because the magnitude of these numbers is actually very significant. So the following table here shows a bunch of different noise sources along with their corresponding sound power levels, first in watts and then in dB. Remember, decibels in mind as we go through these comparisons. SLS is at the top with a sound power of about 202 dB. This is equivalent to the sound power of 2 Falcon 9 rockets, as well as 1,000 military jets, all launching from the same place at the same time. If that isn't doing it for you, hopefully you've heard the sound of a lawnmower before, and can try to conceptually understand what the sound of 15 billion lawnmowers going at the same time would sound like. And that would be the noise from SLS. So in addition to sound power, there are a bunch of other source level characteristics we can use to describe the noise from SLS. When we talk about acoustics, we often talk about source and propagation. And so I'm going to tell you a little bit more about these source level analyses that describe the rocket. The work that you're going to be seeing here was presented at the AIAA Acoustics meeting, which was this past summer in Rome. So more broadly, these source level analyses are known as aeroacoustic characteristics or aeroacoustic scalings. This was a term first coined by the jet noise community, and we're kind of carrying it over to rockets. The big idea here is to see if rocket noise scales to noise produced by supersonic jets, because a rocket is a supersonic jet. However, it's a little bit more complicated because these scalings and models that were built for jets are based on a singular nozzle, or a jet with a singular nozzle. Now, SLS is a lot more complicated as there are 6 different plumes from the 2 solid rocket boosters and the 4 RS-25 liquid engines. Now, in order to apply any of these aeroacoustic scalings and about source, we need to find a way to model SLS's 6 nozzles as one equivalent nozzle. The only reason we can do this is because of what you're seeing in this figure here. We know that the maximum noise is produced about 18 diameters downstream of the nozzle exit, and that's what's shown in this figure on the screen. The 18 diameter point for the RS-25s and the 18 diameter point for the SRBs. Notice that both of these maximum noise regions occur after the plumes merge. This allows us to make that assumption that we can in fact model SLS's 6 plumes as one equivalent plume. Now, typically for rockets with engines of the same type, we're able to easily do this using the following formula. For the Falcon 9, we just take the diameter of one engine and multiply it by the square root of the number of engines in order to get the diameter of our singular effective nozzle. For SLS, this is slightly more complicated because, again, we have 2 different diameters from the engines and motors. However, we follow a pretty similar formula and end up with an effective diameter of a little over 7 meters. In addition to the size of this effective plume, in order to apply these things, we need to know a little bit more about the density, the sound speed, and the exit velocity coming from our effective rocket. These are the numbers that you're seeing here in that order. And again, I'm going to try to put these in context because if you're just seeing these for the first time, probably doesn't mean too much to you. So our effective diameter is nearly 10 times that of your typical military aircraft. So when you're talking about trying to apply these scalings and models that were made for jets to rockets, especially rockets the size of SLS, we're talking about 2 drastically different sources. The sound speed in our rocket plume is 800 meters per second, which is over 100 meters per second greater than that of a military jet, which basically just tells us what we know, that rockets are much hotter and faster. And finally, the exit velocity coming from our effective plume is nearly 2.5 kilometers a second, which is twice that of your typical military aircraft. Okay, great. So we have created this effective plume with all 6 of SLS's plumes, and we're going to use this in order to talk about some of these scaling laws and compare our biggest rocket to supersonic jets. Now, before we do that, we need to make sure that this model we've created actually accurately models SLS's mechanical properties and acoustic properties. So we defined mechanical equivalence as matching SLS's thrust, mass flow rate, and mechanical power. And we defined acoustical equivalence using the following 4 things. You already know what overall sound power and pressure level are. Directivity describes the angle that the noise radiates off the plume. And peak frequency describes the dominant frequencies that the rocket noise is being generated at. I can tell you that our model matched all of these equivalences and allowed us to apply all these different scalings. There's a lot that went into this paper, and unfortunately we don't have time to get into it today, but that was just a little bit of preview. If you have any more questions, I'd be happy to answer them. But Dr. Coyle is going to tell you a little bit more about the propagation behavior from the Artemis 1 mission.
Okay, so one of the things that I'm very interested in right now in my research is understanding the impact to the community of the noise that's coming from all these rocket launches. One thing you may or may not know is that, of course, airports and aircraft have these community noise metrics so that we can say, here's the regulation. You can't launch during this time. Sorry, rockets. You can't, right? You can't, wow, what do you say for planes? What's wrong with me? Okay, you can't take off at these certain times because there's too much noise. We don't have those same regulations for rockets yet. And personally, of course, I think it's a problem. It's my research, right? But so one of the things we made sure we did for SLS, for Artemis 1, was have community locations where we were measuring. So we had locations in Titusville, Cocoa Beach, right? Very far away, and we were pretty confident that we were still going to measure something with what we were setting up. And the purpose of that was to be able to say, okay, well, if it's not going to happen yet, but if we were launching one of these a day, like what is this going to do for like hypotheticals, right? So the paper that is here was a paper that Michele presented at the Acoustical Society meeting in Chicago in 2023. And some of that data we will show here. In order to talk about how sound is going to propagate, we have to understand, right, how is it going to get quieter? Like we all have that intuition, like the sound is going to get lower the further away you go. But what are the things that go into a model so that we can better understand what is the biggest thing affecting this rocket noise? And so some of those things are written here. So sound is going to decay with spherical spreading. That's something that's just like nothing else is out there. I'm not considering anything else, but it is going to decay over a space as far as the further away you go, excuse me. Another thing we can consider is that sound speed, that's a C. So this sound speed is temperature dependent, which you may not be surprised about, but that it is proportional to the square root of temperature. So of course, being in Florida, we have to keep that in mind. We have pretty big temperature variations. I know that's not that big, I shouldn't say that. But for me, thinking about our models, we have to pay attention to, right, when it is being launched during the day is going to affect the temperature and therefore the sound speed. I probably skipped one of these, I'm gonna come back to that. So one of the things we have to think about is atmospheric absorption. So when you know something, there's a lot here, but there is an international standard that is telling me something about the attenuation of sound in air based on the temperature and the relative humidity. And so one of the things that I can say is that at least if we're pretty sure that the peak frequencies for rockets are low, then this is not a big deal, but it's good to keep in mind, right? If we're going to talk about propagation models that, right, if I'm going to be up considering the higher frequencies that we're going to lose more sound as we propagate. And then the other thing I have here is the atmospheric effects leading to a homogeneous or upward or downward refracting atmosphere. So that's this figure up here is like, okay, event, that's a sound wave, I guess, and it's going to propagate up, okay? If there's warmer air somewhere in the atmosphere, right, you're going to have this temperature inversion, which the sound is going to refract away from, right? So we may be able to, without meaning to, right, trap the sound in this kind of sound channel, something that happens underwater a lot, but it could happen for us as well. And then the last thing is ground effect. So if it is a hard ground, then you're going to get a lot of reflections. The sound is going to be greater than if you had an absorptive ground, like, I don't know, sand everywhere. So that's something we have to keep in mind. So all of those things go into our propagation models. And so we have to be a little careful with making sure to not only measure the sound, but also measuring the atmosphere and paying attention to what's going on around the microphone that we're considering. So of course, keeping that in mind, if I'm looking at the overall sound pressure level in dB, time relative to liftoff, these are the community stations that we set up. So you can see, of course, the distances are much further away. This C2 was a sound level meter at about 12.1 kilometers. And of course, if it is the closest of the community noise locations, you should have not only the sound arriving first, but also it should be the highest level. And thank goodness that's what happened, right? You're like, yay, research. And then as you go further away, it's behaving as we expected, which if nothing else is a nice little check on our measurement equipment. So as I said, what I'm interested in is taking these aircraft noise metrics and kind of like Michaeli did and saying, I know it wasn't made for this, but what if I used them? What would it say about the noise that is being propagated away from these rockets to the community? So this is work that I presented in Nantes in August of this year. And, it's the first time from what I know, you can let me know if you find something else, that someone has at least tried this, and it gives some interesting results. So what are community noise metrics? I should watch this time. Okay. Community noise metrics, we've already talked about overall sound pressure level, but what you may have heard before, like from someone with a sound level meter, is like, oh, I measured the sound in dB and it was A weighted, right? So dBA is maybe something you've heard before. So we have a choice on a weighting scheme. So we can have overall sound pressure level. Unweighted, if you ever see a sound level meter with choices, unweighted is actually called dBz. So you're not applying anything to the data. It's like, this is what it is. But if I wanted to make it useful to tell you how loud something was to your ear, then something we do is apply what's called an A weighting curve, because it has been made to mimic the human hearing. So over here in my little plot, I have the weighting curve. So I'm just trying to read my own plot, right? So this blue one is the A weighting curve. And what you see is, right, you've got frequency, logarithmic on the x-axis, and your relative response. And that means, like, for low frequencies, I want to cut that stuff out. It doesn't matter. And you're like, it does matter for rockets, but to my ear, I can't hear that anyway, right? So the human hearing is pretty bad, right? In those low frequencies, anything below 20 hertz, and we have no chance. Okay, peak frequencies for rockets are closer to like 16 to 20. Okay, so if I'm cutting out all that low frequency energy, then what am I telling you about the sound? Not much, it turns out. C weighting, a lot of aircraft noise people use C weighting. It captures more low frequency, but it's still cutting some of it out. What I'm using more recently is this G weighting. And yes, it does cut out the extreme low frequencies, but it actually has a positive up here. That's the only one that has a positive relative response. And basically that's boosting the area of peak frequency that the rocket is making. So that's a nice thing, but it's just not being used very much right now. And so I'm like that advocate that's out there like, use G weighting. I'm a lobbyist at some point. The other aircraft noise metrics is SEL, which is sound exposure level. And so it gives you one number that it's telling you about the cumulative exposure to sound to a particular event. Your EPNL is an effective perceived noise level. That is like a perception. It's very person dependent. I get a little nervous when we start talking about perceptual acoustics, but it is something that is used out there, and you can find EPNL values for every particular aircraft. That is something that's usually published. And then DNL, that might be one you've heard of, day-night level. And so day-night level is something that most regulations have written. So I added this guy down here. So it's telling me like, well, what does a day-night level tell me? The average noise level over a 24-hour period. So you live by an airport and you're like, okay, well, I don't really care how loud that one airplane's gonna be that's taking off. I want to know over my entire day, how is this going to affect me? So they use day night level for that. I personally don't like it, but it is what it is. So day night level for like quiet suburban residential, 50. Cool, dB, by the way. Very noisy urban residential, 70. A lot of airport regulations for housing development around airports are saying 65, that's our threshold. Okay, what they don't always tell you in these regulations is it's using dBA. It's based on dBA. And so if I were to apply day-night level to rocket noise, I'm not telling the whole story. And that's something that, well, again, I'm advocating for more use of different weightings or no weighting. So now we can talk and that should be, we should be able to get the same peak frequency at all these measurement locations. That peak frequency isn't dependent on where you are. And so all these stations were within the, we call inside the fence, like inside the fence of KSC, Kennedy, yeah. So up here, you can see they're all about the same peak frequency, even if the levels are different, right? On the right, what we show is we take that same station 4, so that green line is the same, okay? And what we've done to that curve below is that's that same data with the A weighting curve applied. Right? It tells a very different story. You're like, oh, well, the level's only like 95. I can handle that, right? But no, it's not, right? So we published this in order to show, right, the community that like, if we decide to tell people in these environmental impact statements that it's not so bad, right, with DBA, then again, we're not telling the whole story. So it's something we have to keep in mind. I'm wrapping up, I promise. So in general, like what are we interested in our lab in launch vehicle acoustics? Well, the things at the top are what Michele has done and is still interested in, but maybe for other rockets, we'll see. Stuff at the bottom is kind of what I'm thinking about, like how does this impact the communities? And then all the stuff in the middle is very interesting to us, and they're open questions, like is there a difference between these fuel types that we're going to use with the different engines? What is actually dictating the peak frequency of the noise? And is that something we can control? Lots of other things that we have an interest in kind of moving forward. And very lastly, the why should we care? If you're like, well, I don't have to take acoustics, I don't care about this. Well, noise in general is going to affect you at all stages of your life, not just acousticians, right? And so for anyone working with rockets, launch vehicles themselves, acoustics is going to come in at kind of every stage, right? Like the launch pad itself is designed to decrease the noise from this thing, right? You've got structures that are there to decrease the vibration so that you're saving the rocket itself from itself, okay? And of course the people around, right? Like everyone thinks a rocket is really cool for now, but if we're getting that many launches a day, I have a feeling that the people at the Harbor Point condominiums in Titusville aren't gonna think it's so cool anymore. So yes, you can probably tell, I think this is very cool. I hope you do too. And I'd be happy to take any questions if you have them. Thank you so much for being here and for your attention. Yes.
So I have a question.
Yes.
Have you ever had a launch where you collected data and like, oh crap, you know, I messed up. The instruments were wrong suddenly. Because you can't be like, hey, can you launch it again so I can read it? You can't do that.
Right.
So,
Yes.
has it ever happened? If so,
Absolutely. Yes. I will tell my side, then I'll let Michele tell her side. She's been to lots of launches. Yes. And that is actually a very tricky part about doing this research with undergraduates. Like we have a very limited amount of time to get the data, and with SLS, like this is gonna happen once, right? And then Artemis 2, that will happen once, right? So if we mess up, like it's very scary, right? That you can't repeat it and you can't control it. Like I have nothing to do with the launch schedule, and so getting that data is like we really hope it helps. But yeah, I'm gonna let Michele tell her story because she's got a lot of those.
So I've been to a lot of launches in California, in Texas, in Florida, and Virginia through doing this research. And I've had plenty of mishaps, whether it was my fault or someone else's fault. I usually work in large groups. It happens. We typically set up a lot of measurement stations with the hope that like 90% of them work. But unfortunately, that is just one of the parts of the job. Yes. Yeah, so I was at, well, I can't give like specific details. I was at a rocket launch one time where we were asked to set up arrays of microphones 60 meters from the rocket. And I was just helping out on this project. It was like funding a graduate student. But unfortunately, we were definitely ill prepared, and a lot of our equipment just ended up kind of blown away. So there's definitely lessons there. Got to go through. It's unfortunate and unfortunately very expensive, but it does happen, and we learn from it. And we successfully did a similar measurement on a different rocket this past summer. So, it kind of cycles through. You just build off.
Great.
So the first one was, so earlier you mentioned that the peak noise was about 18 diameters from the your exit. How did you guys arrive to that? Was that just through testing and validation? How did you get to that?
Okay, so the very peak noise is 18 diameters downstream. The dominant noise region is like 10 to 30 diameters. And that comes from a measurement of a GEM 60 booster static fire in Promontory, Utah. So when it's horizontally fired, it allows us to really understand the noise sources in the plume better, because during a launch, like you have a deflected plume, and that obviously contaminates the noise region until the vehicle is up and away from the launch pad. So the way that we did that is we used multiple microphone probes. We call them intensity probes. And this allows us to get basically vectors that describe the magnitude and direction of the noise sources within the plume. I'm happy to give you more information. It's a lot more complicated than a 2-sentence explanation, but basically you have to use multiple microphones, and because you have microphones in multiple dimensions, you're able to get vectors that show you where in the plume the noise sources are located. I'm happy to show you the paper. I was not involved in the measurement, but I read it many times.
Computer modeling of acoustics as part. Was this, from what I'm seeing, most of your work involves open air, sort of external environments. Did any of it involve more internal, like closed geometry?
So far, no. We're definitely interested in the measurements of the launches, like live launches that are happening. The modeling that I did, it was for my my master's thesis. I did some computational modeling, and when you're doing that, right, if you're doing some computational modeling yourself and you're trying to simulate, right, an open environment, it's tricky. So one of the things you're doing is you're actually simulating an absorptive barrier at the top of your computational space. So even though like I can't simulate completely open air, I just make a choice about where do I care to stop that simulation without making reflections coming back into my computation space. I'm not sure that's going anywhere close to what you're asking, but no, maybe, yes. Okay, cool. Okay, so measurement-wise, though, no, we're not taking any interior measurements, at least for now. Yeah. Other questions? Sure.
So, from your point of view, I want to know what's next. Like, you have the data, you present the data to lawmakers, right? And you can't change the fact that there's going to be more launches, right? So what do you want to see done?
Yeah, great questions. Totally forgot to repeat the question, so I'll do that now. So what is next? Basically, like whatever I find, what am I going to do with it, and what do I hope to happen? It's not that I want launches to decrease. I think it's very cool, right? I think what I would love to see is that we're just more honest about what's happening. I think like every environmental impact statement that I've read, like the one in Boca Chica or down in Cape Canaveral, I'm always like, guys, like it's not the whole story. It's not that they're giving us false numbers. It's just if you're going to tell me something in DBA and it's about rockets, like it's just not, that's not what we need to see. The problem is there would be necessarily more education if we're going to start using different types of metrics. We would have to say, okay, well, if we're going to use G weighting, we need to tell everybody what it means, because everyone already has a good feel for like, what is 65 dBA, like in that community, right? So if you're going to start using a different metric, it would take a while to take hold. I don't know if I'm the person to like make them do it, but I think it really is more like we should be giving more information. One of the things I say in my paper is like this noise, like a noisy environment is affecting things like, you wouldn't be surprised, sleep, children's educations, being really intense about that, but also like property values, right? Like it is a cool factor to have these rocket launches all the time, but if the people who bought these properties on the Space Coast are like, wait a second, I didn't sign up for this, then they're going to suffer too. So I just think it's more about information and being honest. Yeah. Thank you. Yes, please.
Okay, I have something quick to add. I think it's important, like, that you guys understand that all of the research done about rocket noise stopped in the 70s and it has not been picked up since the past like 5 years. And so there's a huge gap there, and that's what we're beginning to try to fill. And like ultimately, like Dr. Coyle talked about, there's like these propagation effects, but there's also some source level things that we can do. If we can understand if like which rockets are generating more noise than others based on their nozzle configurations, what type of fuel they're using, they can be designed in a different way to mitigate that noise if they're going to be continue to become bigger and bigger. That was just my addition.
Great. Well, thank you guys so much for being here. I'm now 5 seconds over, so I will give back the floor.
All right, that was Dr. Coyle and McKaylee. Thank you guys for sharing about your acoustics research. It's very interesting to see aerospace from a different perspective. So thank you. Let's give her a round of applause.